And welcome back to the morning show. It's Wednesday, Wise Guy time. Matt Sellen is back here, and Matt, it's cold outside.
It's really cold. And one of the things that I noticed, you know, when you're driving around outside and it's one of those really cold days and the snow is crunchy and it's crisp and clear, it's always kind of crisp and clear. When you look up, the sky's blue, and it's always that way when it's a very cold day. That it's very clear outside. And I thought, let me see if I can explain why that is.
Okay, it's deceiving because you look out the window and you're like, oh, it's nice and sunny, and you walk outside. No, it's not.
It's a beautiful sunny day, and you know, it is really beautiful and sunny, but a few seconds later, you go like this.
It's
when I
warm.
put my little beagle out on the back porch, you know, this morning, she looked up at me like, you got to be kidding me. I don't want to go out there. I'd rather go pee in the basement.
Sure.
So anyways, so it all has to do with, well, clear means there's no clouds or mist. Right. And clouds or mist are made from little water particles. So that would be little tiny drops of water which are suspended in the air. And so the question is, how do you get rid of those things? And the answer is, it has to do with pressure and temperature.
Okay.
And so when cold air comes in to a system, like come over, you know, Champaign-Urbana area, the cold air falls relative to the warm air that was there before. And so we can illustrate this right here. I can show you that warm air rises. That should convince you that cold air does the opposite, because the cold air goes down to replace the warm. And I like this little, it's just a hairdryer on a stand, really. And I like this thing because it's a big giant silver weenie.
Yeah. Looks like a windsock.
Yeah, exactly. So it's like a big hot dog or something. And so if you just run a little bit of warm air in there, now the air inside is warmer than the air around it, and when we let it go, it just goes and stays up there.
Ah.
Now I hope it comes back down because I have to return it.
Yeah.
Come here. Oh no, it's stuck on a hook. Oh no, there it goes. Okay, so the hot air rose really quite rapidly, so you can see that cold air would sink if it was in some warm air.
Sure.
Okay.
Got it.
So when cold air sinks down, what happens though is then more cold air replaces it over top, and it just keeps sinking down.
Okay.
And up in the higher part of the atmosphere, the pressure is lower than in the lower part of the atmosphere. So when the cold air goes down, it actually warms up.
Oh.
Okay, and that warming of the air is what gets rid of the little moisture bubbles or moisture droplets, because that changes the dew point of the air. And so that means that air which was cold and had mist suspended in it, when it warms up a little bit, it can't have mist suspended in it because suddenly the dew point is lowered. And so what we're going to do here is I'm going to illustrate that. Here I have, I have a little bottle that water's been sitting in for a while.
All right.
And that means that there's a little bit of water vapor up here. You can't see it just because there's nothing for the water vapor to condense on, but if I put a little bit of smoke in there, like that, okay, sound effects are very important.
They were good.
Yeah, okay.
I like that.
And you crank that on, and now you can't really see much in there. I'm going to squeeze this thing tight to make the pressure big inside, and then when I release it, you see how it got misty? Now, there's a mist. Let me increase the pressure. That's going to warm the air a little bit, increase the pressure, see the mist go away.
Very good.
Okay, so this is what happens. When you have misty air up high, it goes down, the pressure goes up, and it sort of warms up a little bit, and it clears up. Okay, so you can really see the difference, so you can see. Okay,
very interesting.
Yeah, so that's kind of neat. And so what happens is all that air piles down, the cold air goes down, more cold air replaces it, so now you have a column of air which is thicker than you had before. That also means that the barometric pressure is bigger. So if you look at the barometers you have in your house, when you have one of these really cold, clear days, the barometric pressure is going to be higher.
Right.
Because there's just more air piled in there. The air is denser, the pressure is higher than it was.
Very good. So we'll continue our meteorological lesson in 30 minutes.
Right, we will. We're going to talk about measuring temperature and about wind chill, because that's something that people are confused about.
Yeah, and something that everyone is feeling right now. Yeah, very good. All right, Matt, thank you very much for your time. We'll check back with 30 minutes. But first, let's go to the girl who probably knows everything we're talking about, Jennifer Ketchman.